There is a rectangle ABCD that has two sides, 4 and 2. Solve for the maximum value of area addition between the triangles BPQ and DPR. First, if we first solve for this question, let's think about the properties of our rectangle. Our properties of rectangle is that the sides that are parallel should be same. So that means we can think about this in this way. So at first this side is 4, which means the parallel side, which will going to be BC, should be 4. Now DC is equal to 2, which means the parallel side, which we're going to be AB, should always be 2. So we used our rectangle's property. And now, let's think about as a step of solving for this question. So at first we need to know how to solve for the area of the triangle. The area of this triangle. So if you think about the formula for finding the area of the triangle, it will going to be the base times height, the height times 1 over 2, or divided by 2. This will going to be one of the most important thing when it comes to solving for this question, how to solve the area of our triangle. So for the area of the triangle, the areas that we need to find is that first there are two triangles BPQ and DPR, but our final or ultimate question where the answers will going to be the maximum value of the area addition, which means we need to solve for the area of its triangles first. Triangle BPQ is right over here, BPQ, and triangle DPR is also DPR. And we can think about this P point as the most important point in this question. The reason is because these both triangles includes the P point. It's time for us to think about the patterns in the geometry function problems. The reason is because when it comes to solving for the geometric function problems, the relative functions problem, it's hard to solve for it if you don't know exact pattern for it. So the pattern is whenever there is a function as geometric problem, we need to always think about it as x and y axis. This is our pattern. All you have to memorize is we need to always think about the patterns in the geometric function x and y axis so that we can solve this even easier way. So at first, if you think about the x and y axis, so the x and y axis, x-axis, so our x-axis should always be the horizontal line. And if you think about the y-axis, it should be the vertical line, unlike our x-axis. So our y value should be a vertical line. So simply, when it comes to the patterns, all you have to memorize, we need to convert this into an x and y axis. Which means from here, we can know one thing. From the BC, the point BC, we're going to be the horizontal line. Which means we can think about these terms right over here as the x-axis. And for a BA, it is a vertical line, which means we can think about this also as the y-axis. So we can write it down. We can write that for our horizontal line, which will going to be the x-axis, the BC, we can write it as x-axis. For the BA line, which will going to be the vertical line, will going to be the y-axis. So the most important thing in this question is if you can convert this into a x and a y-axis when it comes to solving this question. And more than 90% of the geometric function problems, we always need to convert this into the x and y-axis to solve the question. At first, let's solve for the P. So for the point P, the reason why you're solving for a point P is because as I have mentioned, it is the most important point in our question. So for the point P is located right over here. But then we cannot know the point P easily because it includes the unknown variable. But we can write it in this way. Every single coordinate can be written as x, y, where the x is equal to the input of our function, and the y is our output of the function. So this is going to be what the x, y is. But from here, we can know one thing. The point P, so the point P is on the straight line, which means it is satisfied. So the point P is on some particular line, which means this point P satisfies our equation for this line. So for our line, every lines are formed by the linear function. The linear function. And if you think about the basic format of our linear function, it will going to be y, which will going to be output is equal to ax plus c. Now let's think about what a and c is. So for the a, so let's write it down here. The a value will going to be the slope of our function. And for c will going to be our y-intercept. This is what the linear function's basic format is. Now, let's actually solve for it. At first, let's think about how to solve for our slope. The slope will going to be x, 2, or 9, or it can be as triangle format. What it means by triangle is horizontal divided by the vertical. So divided by the vertical. And this forms a specific triangle. We call it as triangle formula. So this will going to form our slope particular function. So at first, let's think about what it is to be the horizontal line. Our horizontal line will going to be 4, which will going to be BC and then AD, divided by vertical line, which will going to be AB and DC, will going to be 2. And it will going to give us the output 2. But we are not done yet. If you look at where the straight line is located, it is going toward the negative signs. So our slope won't be 2. Our slope of our function will going to give us negative 2. So our function will going to be y is equal to negative 2x plus c. And we need to solve for the c. And here, there is a way for solving it. So here's our way to approach this. We know that c will going to be the y-intercept. And if you think about the definition of y-intercept, it will going to be when the input is equal to 0, our y value always exists. This is what our x-intercept will going to be. And if you think about this into a specific format of the function, our y-intercept will going to be this point where it's on the y-intercept when the x value is equal to 0. And that line, this line, will going to be positive 2. So we can form this in this way. Our c value, our y-intercept, will going to be positive 2. So we can finish our function. Our linear function for this question will going to be y is equal to our slope negative 2x plus our y-intercept 2. And now we can use our property that our point P, and now our point P, which is the most important point in our quadratic function, this geometric problem, will going to be satisfied in our quadratic in our linear function y is equal to negative 2x plus 2. Since we need that, it is on that linear function. So at first we can also set our p-value, our p-coordinate as x comma y. And we can also know that x is the input of our function and y is our output of our function. But then our p-value, we don't know our x value, so we can simply set it as x. But then we can know the y value. If the input of our function is equal to x, all you have to do is we need to input this back to our original function. If you input this back to our original function, this will going to be y is equal to negative 2x plus 2, the same. But then our y value will going to be y. So we don't have to write our y. Our y value will going to be negative 2x plus 2. This will going to be what our p point will going to be. And now all you have to do is solve for the area of our specific triangles. So at first, let's think about what triangles we need to solve, or the areas, triangles of areas that we need to solve. So at first, there is a triangle PRQ. And secondly, there is a triangle P, so there's DPR. The most important thing in this, among these triangles, are that these three triangles include the point P. This will going to be the most important things in our equation, and we can write our triangle down in more neat way. So at first there was a triangle BPQ, another triangle DPR. And actually, let's solve for our triangles area. So at first, let's think about the triangle BPQ first. Let's write our formula down again. Our formula to solve the area of the triangle was base times height, height times 1/2, or divided by 2, and because they are the same. So at first, let's simply write down our 1/2 first. So 1/2 times something. But then if you think about the baseline of the triangle BPQ, so the baseline of triangle BPQ, which will going to be BQ. But then we can think about this in this way. For the baseline of the BPQ, it will going to be BQ. But then it will going to be same with our p values, x value. So we can write it our baseline as x. And now let's think about what it is to be the height of our function. So for the height will going to be this one, which is same thing with the p values, point p's y value. So the y coordinate. Now our y coordinate will going to be, as we have proved it here, negative 2x plus 2. So if you simplify this, it will going to be our area of our triangle. Before we simplify this, let's think about one more triangle, which will going to be DPR. Now let's write our functions. Let's write our triangles formula down again. Base times height times 1/2. And at first, let's write our 1/2 simply down again. And for the baseline of our triangle DPR, our baseline is equal to PR. But now, for our base of the triangle, so base of our triangle DPR will going to be PR. And now we can think about this in this way. So for the PR, it is same thing with subtraction from the 4 to our line right over here. So PR is same thing with 2, which is 4, which is our RC, or it can be AD, minus our original P is the y coordinate, which will going to be, but if you think about the line from here, it is same thing with our x coordinate of our point P. And our x coordinate of the point P will going to be just x. So our PR, which will going to be our baseline of our DPR, will going to be 4 minus x. So we can multiply 1 over 2 multiply 4 minus x. Since we knew that our baseline is 4 minus x. But then we need to know the height of our function. And for the height of our triangle, DPR will going to be dr. And same thing here with the same concept and logic. dr is same thing with total of this, subtract from this line. Our total line will going to be 2. So at first this will going to be dr. It is equal to 2 minus, so 2 minus our RC, which will going to be our y coordinate of the point P. And our y coordinate of our point P, as we have seen here, it will going to be minus 2x plus 2. And we can simplify some of the things here. 2 and a negative 2 and a plus 2, since there's negative, we're going to cancel out. And the negative 2x will turn into positive 2x, so we're essentially multiplying 2x. However, we made a mistake here. Our mistake was, so after dr is same thing with 2 minus our y coordinate over P, it will going to be, so our y coordinate will going to be something, and it will going to be 1 over 2x. So this will going to be 2 minus 1 over 2x, but we still have our plus 2, and we can take our 2 off. If you simplify our calculation, minus 2 and a 2 are going to cancel out. We have minus 1 over 4, 1 over 2, which will going to be positive 1 over 2. We have x, so we can just put it x here. But then we can simplify even more. 1 over 2 times 1 over 2 will going to be 1 over 4. And then we can simply set x. So if you write in a more neat way, so 1 over 4 times x times 4 minus x. This will going to be our triangle DPR's area. So at first we made a mistake here, since we knew that this will going to be 1 over 2, not 2. So all you have to do is we need to simplify our calculation. 1 over 2x times negative 1 over 2x plus 2. All you have to do is we need to use our discrete property in order to cancel out our parentheses. And we're going to get negative 1 over 4x squared, then plus x. Let's think about the other one. The other one was 1 over 4 times 4 minus x times x. So this will going to be, simplify this, you will going to be negative 1 over 4 x squared plus x, which is exactly the same thing with the upward case. But they said we need to solve for the addition, which means we need to, all you have to do is we need to multiply this times 2, or added both of them. So it was negative 1 over 4x squared plus x. So all you have to do is, our original function was negative 1 over 4x squared plus 2. And then we also have one more. All you have to do is we can multiply 2. So we can write it in a more neat way. So this will going to give us negative 1 over 2x squared plus 1. We made a mistake here. This should be positive 2x. Now it actually turned into a specific function problem. This will going to be the addition of our quadratic functions addition, which will going to be the two triangles areas addition. But then our goal is to find the maximum point of our function. But then we need to set our domain of a function. And if you don't know what the domain will going to be, so if you think about the domain will going to be the range of x coordinate. The reason why we're doing this is because we need to see the exact maximum point of a quadratic function. So let's draw a approximate value of the function. Since we knew that it is going, it is a negative value, the graph will go downward, which means it will going to only contain a maximum point. And the maximum point will going to be x, comma, y.